Hi everybody, this is a video about solving memory forensic challenge from CyberDefenders. I read about this challenge from a tweet from my friend Zvika Maisans, and if you check it, they have some new challenge called DumpMe. It's a memory forensic challenge, and as it's a challenge based on work with volatility, and I really love volatility. I was quite interesting about the questions which are in this challenge, so I basically jumped to it and check the questions if I'm interested in or not. Basically what I'm interested in is there is almost always at least one misleading question in memory forensic challenges, and usually also even the creator of the challenge is not correct about the right answer. And I want to check this question, and I find out that this is also the case where one question is really misleading, and the correct answer is different than the creator expect here. So I will come back to it later. First of all, I would like to here is the say about challenge details. One of the SEC analysts took a memory dump from a machine infected with a MetaPetra malware. So basically they say oh, what infected the machine, and as a digital forensic caters, your job is analyze the dump, extract the available blah blah blah. Volatility 2, they are recommending the volatility 2. And this is quite important because if you would try to use volatility 3, it could produce you different answers, and they would not be correct. So I use volatility 2. I will be using volatility 2 and volatility 3 because volatility 3 is in some way much faster and better, but in some way it's worst. And but what is advantage of volatility 2? That there are far more plugins and it's more reliable, still more reliable, because volatility 3 is newest, it's faster, it's very good, it's based on Python 3, but there are not too many plugins, and also there are still some bugs, yeah, because volatility 2 was developed quite for a long time. Challenge question, you can see it here, and I basically start with registering because I wouldn't be able to download the challenge if I would not be registered. So I registered and scroll a little down so to check the question. And what I found quite interesting is this question 8. What is the MD5 hash of potential malware on the system? It's a basic misleading question because what they are expecting here is not correct answer. Yeah, I will answer this question right, what they are expecting, but this is not correct answer, and I will show you later. Okay, so we can jump to question 1. First of all, download the challenge and use volatility 2 as they suggested. The password for the archive, if you try to download it, is a C47 imposter zip archive, and the password is CyberDefenders or ORG. Okay, so I already prepared it, and first of all, I already prepared. Here is the unpacked memory image and from zip archive, and I want to prepare something. First of all, I will be using PowerShell because it has a command line history, and I would like to assign some variables and work with pipeline and working with grep alternative, Linux grep alternative, which is select string in PowerShell, and other stuffs. You will see that it's quite interesting, and I hope this video also serves you for some guide, or you will learn some tricks, maybe. Hope so. So first of all, volatility 2 and volatility 3. I will be using both of them. I would like to be fast enough. And here you can see that I already prepared BViewer, which is basically bulk extractor and graphical user interface for that. I will show you how and for what purpose we will be using that tool. So basically we will prepare the one thing. I would like to save a path to our memory image dump to some variable in PowerShell to use it in volatility as a variable and not as some long path. So variable memp dump equal, sorry for that, equal and path. Copy this command and copy it to PowerShell, which is in the path of volatility free. Here. Window, volatility free, volatility 2. Yes, yes, and now we are prepared. So first question is SHA-1 hash of triage man of the memory dump, and second question is what is the profile? Okay, so they are asking about the profile, so basically they are using volatility 2 because volatility 3 is not working with profiles. So jump to volatility 3, here PowerShell, and get file hash path our variable memdump and algorithm SHA-1. Okay, and the second question was profile. So well, Python 2 f file will be our memory dump path. And basically, yeah, it's a Python 2, so we have to specify that I would like to use Python 2 because I have defaultly set Python 3. Python 2 whereby and volatility file memdump, and the plugin is image info to get some information about profile suggestions and other stuffs. Maybe we have, yeah, we have already first answer here. This is this hash, submit, correct. What is the third question? ID, process ID of notepad exe. So come back to volatility free, and you can do something like this. Wall by a file image, our image path, so our variable, and we can basically print help because we want to see how it's defined the plugin volatility ps list. And for next time I would like to grab this plugin. So basically, if you want to list only the plugins here, so you can do it like this in PowerShell on volatility. Select string, and you can do it like Windows dot and simple match to not using regular expression with select string. And you will get only the plugins for Windows, and here is the Windows PS list. Nice, it's for volatility free. So arguments f memory path, and plugin is first of all our plugin, yeah, like this. That's all. You don't have to specify a profile because it's volatility free. And if you want to find the notepad, just select string and find notepad. Nice, we have it. Here is the process ID Submit it. Okay, correct. Here you can see the output of volatility 2 about the profile, and you can see here many suggested profiles. Based on my experience, the last one is the most accurate profile, this one, but if you check the answer what they are expecting, 1 2 3 4 5 6 7 8 9 10, they are expecting 10 letters, and 10 letters, it's basically these are too long. And why do you have so many suggested profiles is basically because Windows Service Pack 1 and Windows 2008 are very similar address memory space, so the structure is quite similar, so the volatility is suggesting too many profiles. But in my experience, the last one is the most accurate, but they are expecting the first one. I don't know why, but it should be correct. Submit, and it's correct. 1 2 3. Question 4. The name child process of W script exe. Okay, so we need to use PS3. For example, we can use volatility 3 for that. It doesn't matter. It will be faster. PS3 is here. Copy that and run, and find W script here, and this is some name of the child, and it has another child CMD, but they are the question is about this. Name the child process of the W script here, submit, and it's correct. What was the IP address of the machine? Okay, there are a question. There are questions about network related artifacts, so I want to show you one quite tricky thing. So we can use bulk extractor for this, but we will be using also volatility plugin. So first of all, to run bulk extractor and uncheck all of these, because we don't need to carve these record stuffs, but only thing what we need is to use scanner net, because it's able to carve out pcaps from memory dump. It's really useful. I'm using it quite a lot. So now specify the memory image, volatility, and all files. Here's OP directory is the same path, volatility select, and that's all. Submit, run, and it's running. So we will carve out the pcaps and we will confirm our answers. What is the next question? Next question is also on the network artifacts. Okay, so I will show you that we can find out this information also from the volatility plugin. So we can use plugin netscan, but we have to, it's volatility true, so we have to specify profile. And the suggested profile is this one. Okay, we can use this one, it doesn't matter. And the plugin is netscan. Nice, we will run it. So this is one question, 2, and how many processes are associated with VC runtime 1 for ODLL. Okay, so we will be using DLL list plugin, and I think the volatility 2 is better for this, because in my experience volatility 3 is not as accurate as volatility 2. Okay, I will check if here is some information about it, and here we have some network information, basically something like netstat, sockets, and other stuffs. You can see local address, local IP address, looks like it should be 10.0.0.101. And what was the next question? Based on the answer regarding the infected bit, can you determine the IP address of the attacker? Based on the answer regarding the infected bit, can you determine? Okay, there is no question about infected bit. It's really funny. Basically, yeah, you can consider that a W script running some random generated name exe file is basically this could be the malware, or this could be or the malware which is the original malware could be the sample which is running the W script or other stuff, but there are no related question about this. Yeah, so okay, I will try to figure it out based on the answer regarding can you determine the IP of attacker? Okay, I will try that. So if you check that, they are probably they mean the strange process name. You can see it here, and if you check it, it has established connection to IP address 10.0.0.106 and port 4444. And as they mention that it's a Meterpreter, that it was infected with Meterpret malware. Meterpret defaultly config is the listener is basically to connect to reverse shell on port 4444. So yes, it should be the what they ask for. So I think the attacker is this IP address, which is this question, and my IP address. Okay, this ended the bulk instructor, so we should have some carve out pcap. You can see it here. Yes, nice. Don't need this, don't need the report, but we need pcap. Yep, and Varshak, show me what you got. So here you have it. It should be our source IP address, because you can see it here. Source, so many source. Okay. We can filter it out. We can specify that we want to filter only this IP address, not only source. ADDR, and try to find out something interesting here. Maybe you could find out some related information about 4444 TCP 4444 port. Basically, it's a connection to RVM, so it's a direction from the remote to local. So yes, this is the attacker IP address. Basically, we found out in a volatility plugin. If you want to check it, you can see it like this, and select it and change this source to ADDR to be specified as source, and also the remote address. And you can see here that there is in the carve out pcap there is only network traffic cached the response. Yeah, basically, if you establish connection, we are the source, this is the destination, but here you can see that yeah, it's a reverse shell, so basically they are connecting to our port. Nice. So this should be the IP address of the attacker. As you saw here, local IP established to here. Okay. Submit. Okay. What I did wrong? What was the IP address? Yeah, it was the IP address of the machine. So the machine is this one. Submit. Okay, and it's done. How many processes? And as you saw, there are so many nice, interesting information in the carve out pcap. Yeah, you can see there are plenty of it. This look quite strange, but I know that something like this generate Google Chrome, but I'm not sure about this. Yeah, it could be quite investigated, but there is no time and no questions about it. So this is quite interesting too. Yeah, but okay. you can see here something. Okay, but you can see here the MemoryForensics session. We are not interested in this anymore. We can delete the pcap. What are the questions next? How many processes are associated? And okay, we can do it with the DLL list plugin in volatility 2. It's the best way probably. So we can use DLL list and pipe it and select string here, and we could get some information in how many processes it's in their memory range. 1, 2, 3, 4, 5. You can see the creation time is different. We can probably get some more context in which process ID, but it doesn't matter. It's really different because there is why the process would be loading the same DLL 2 times. Yeah. So 1, 2, 3, 4, 5. Okay, and 5. Submit, and it's correct. What is the MD5 hash of potential system? Okay, we correct, and 8. This is the most interesting question for me and the most misleading, because what is the MD5 hash of potential malware on the system? First of all, if when I read it, I thought like okay, where can I find the real MD5 hash of the original sample which was run? It's quite almost impossible. Yeah, there is AM cache. AM cache in its database, it's holding information about hash, but the AM cache plugin is quite not so reliable. So I tried and it failed. Yeah, so I was thinking about, yeah, it could be quite advanced, but what if they want only to dump the process with volatility 2 and calculate the MD5 hash? But this is not saying with this question what is the MD5 hash of potential malware on the system. Okay, I will show you what they're expecting, but it's wrong. It's so wrong. Yeah, so we can basically do like this. As they are MD5 potential malware. The potential malware is the process where is the MemoryForensics session. So it's the strange name. If you specify like PS list, and if I understand, they are expecting to use volatility 2 to process dumping. If you dump the process in volatility 3, the MD5 hash is different because it's a process memory dump. Yeah, it's not the original sample. It's not the potential malware on the system. Yeah, it's not. It's so wrong. Yeah, so basically, if you if you would not use volatility 2 proc dump plugin, you will be always wrong with the MD5 hash. This is the correct, but the other way is it's free. It's quite a nice challenge, a MemoryForensics challenge, and they are like they are helping you with four first character of the MD5 hash. So it's quite helpful, but it's wrong. I will show you. So you can see that they are expecting this process. Its process ID is 3496, so they are expecting to use procdump plugin, pit this one, and D as a dump directory dot. And it's done. We dumped the process with procdump, and if you check it, it's here. And if you calculate the file hash, get file hash dot, and what was the file name? Executable. And you can see, okay, sorry, and algorithm would be MD5. here is the hash, and if you copy that and submit it, it's correct, but the real answer is different because this is not correct. What is the MD5 hash of the potential malware on the system? MD5 hash is not fuzzing hash, it's so different. 1 byte is different and the all hash is different. So wrong. So I would like to show you what is the right question, what is the right answer. I would like to introduce you a new tool. It's based on PE3. PE3 is a very, very nice tool. It's available on GitHub. It's an open source tool. It's based on Python 3 and it's absolutely phenomenal because it's also working as a plugin for IDA Pro, and I will show you. There is an extension for PE3. They basically released it like 5 days ago. So I would like to show you this, how does it work and why it's so good. So we can use PE3, and you can see there are more extensions in PE3. PE3 carve, it could carve out the portable executable format file from a binary file. There is another extension for Guitar and another for Minidump. It could repair and carve out the main module from Minidump, and volatility, and it's based on volatility free. And what are the arguments here? You can see that one argument is only the file name path to memory dump. So specify our variable memdump. Yep, and it's running, so just wait for it. And what you can see now, it's really, really nice. And I really love it. You can see something like task viewer, yeah, based on the memory dump. You can see basically these are properties from the PS list nicely. And what you can see here are here is our interested module. You can see it here, and if you select it, you can select it alone, the main module of the process, and you can select all of them. But I am interested only for of the main module. Dump it, and you can see here. And this is the PE3 tool. Phenomenal. I really loved it. You can see almost everything. You can see hashes, IMP hash, import hash. Yeah, basically import hash is very, very interesting and important. I will show you why. And it's basically hash from the API function name which are in the import address table. They are used with this malware sample. You can see here image DOS header, DOS stub, and NT headers. You can see optional header, NT headers, optional header. Yeah, something. Hey, it's so useful. But I want to show you one thing. You can see it here. But first of all, when I wanted to answer this question correctly, I tried to look for the IMP hash because it's fuzzy hash, and I can find some similar sample, maybe the one, and I use online tool for finding malware sample, and it's called virus share. Yep, login. And basically it's very useful because you can search with the IMP hash like this. But if you try to find the sample with the IMP hash, you will find quite many samples. So many, 1 to 20, but there are many pages, yeah, many pages, many. So another thing was that you can specify some exit data, and there is the timestamp where the file was created, yeah, the file was compiled. So here is the compile time, here in P3 is the compile time here. And if I specified it, I found out after many trying to search this sample, I found out that virus share doesn't have this sample, the right original sample. It has similar sample, almost very similar, but not the right one. So I try to jump back to the basic, really basic, jump to the start, and I try to what I really didn't think that it could work. Yeah, because it's really basic. But what do you do if you don't know what you do, what you want, and what you do? Basically, you are trying to Google everything. So when I saw the, you can see it here, you can dump this process from PE3, dump it, and it suggests you that it could, the PE header and address of entry point, that's all correct. I don't want to recalculate the PE header, I don't matter about that, but keep existing import address table, rebuild, and rebuild from existing. No, I want to keep existing, because if you saw here, if you check it here, import descriptor, you can see that all imports are resolved nicely. There is no warning. It's a really nice tool. So I don't want to repair anything. Dump it and keep existing, and save the file and save it to here. Okay, saved, and minimize, and you can see it here. If you try to check it in, first of all, as I tell you, you have to jump back to basics. Just copy this file name, just copy the process name, and try to Google it. Because if you try it, you will find out that there there is the sample which has the same name in the any run. If you click on it, you can find out that there is the same name. It could be the same sample, but it doesn't have to be. So first of all, copy the MD5 hash and jump to virus total. Search the hash, go to details, and if you check it, what we got here, basically IMP hash is the same, 401 ending 440, 401 440, and you can see here also that the compiled time is 2009 09 22 10 45 34, the same, absolutely the same UTC time. So the compile time is the same, import hash is the same, and what could be interesting more, we can try to check another stuff. We can try to check another stuff, sorry for that, bless me. And we can run another instance of virus total and put the memory dump there. And go to details and compare the results. You can see that which PE header is the same. So another evidence that this is the same sample. But the most important is also here, file version information, absolutely same information, absolutely. IMP has the same, file version information the same. There is also reach PE header hash the same. SSD is almost same, but there are difference because this is the dump from memory. Yeah, so the hashes are so different. They are changing. There is changing so many stuffs. But I wanted to show you is also that here this is the real sample from the any run, the original one. And if you check it here, you can see that the virus total has a section hashes. So this is the this is the time when I started to be 100% sure that this is the correct sample, because if you check the PE tree and go to NT headers and section header text, for example, check the hash CCB A34 CCB A34, the same. You can check, for example, resources. They are not changing because what is quite important to say that our data and data are most likely to be changed. This is the memory dump, so it's already repaired from virtual address space to raw address space, but if the malware is unpacking something or patching something or doing some changes in its memory address space in data section or something like that, the hash will not be the same as it was in the original sample. But you can see that in the text section the code was not modifying itself in the runtime, so the text section is the same. And resource, you can see here in resource C13 and 389, 381, the same. So the section hashes are the same, IMP hash the same, PE header hash the same. This is our sample. Version information the same. Yeah, original product name the same. Compile time, and this is more the most important, is the same. So basically what we found out is that this is our sample and this is the correct MD5 hash, EA4 ending 2D5. But if you check here, they are expecting absolutely different MD5 hash. But it was quite a note for the future that there is always some misleading information, and even the originator or even the creator of the challenge, it doesn't have to be correct in expecting answer. So basically you can report an issue here. Maybe if the issue is about how to solve the question, please our Discord server. If it's about how to solve the question, no, we can basically specify copy wrong expected answer this is original sample MD5 hash is this one. You are expecting the hash of dump process, which is changing, depends on used tool MD5. And what we got here, I copy that. Yes, I think about it, that it will happen. So question 8 is here. Report issue. Paste it wrong expected answer. This is the original sample. MD5 hash. Correct answer. Correct answer, this one. You are expecting the hash of dump process, which is changing, depends on used tool. MD5 expected wrong hash, and they are expecting the one we already calculated here somewhere. Here, this one. Okay, report. Thanks for your feedback. Nice. We can come back and question 9. What is the LM hash of the Bob's account? Okay, I'm 100% sure that I know the answer because there is nice plugin in Volatility 2 for that. Clear window, and we can do like this. By Volatility 2 help and select string. And LM, because they are answering about LM hash. You can see hash dump is the plugin here what we have to use. So like this. And LM hash is their question about Bob's account and A83 is starting. You can see it here, Bob account and A83. This should be one. Should be okay. Submit, and it's okay. What memory protection contents does the virtual address descriptor note at this address? Okay, it could be quite an easy one. Just jump back to Volatility 2. Clear and try some plugin name which is related to virtual address descriptor, and you can find out that there is some plugin, and I am interested in BAT info, virtual address descriptor info. BAT info, and we can basically select string, and we can specify the context, because I don't want only the match line. I want to some lines before and lines after. I want to see the context. So 5 lines before and 5 after. Nice. And it's working. What is the next question? What memory protection did the word virtual address descriptor starting at this? Yep, this should be the scenario. There was a VBS script that ran on the machine. What is the name of the script? Submit without file extension. Okay, we could probably check the command line arguments. Let's check if Volatility 3 has a command line plugin. You can see Windows command line, yeah, here. So we can use this. Volatility 3, let's start it. Yes, and if we can, yeah, we can check it here. There is some VBS script in W script. Okay, that was easy one. And without file extension. Submit, and it's correct. Check what we have here. You can see that the virtual address descriptor, the address here, node, it should be node address. What memory protection constant does the virtual address descriptor node? And you can see here the node is here, 5 lines before match and 5 lines after, nothing here. So you can see node address is here, is basically what we specify here. And what is the memory protection page read only? Copy that, answer, submit, correct. What memory protection is virtual address starting at this address and ending this? Okay, that's the same, basically copy. You can do the same, and you can specify it like this. Okay, and let's check. The application was run, and yeah, there is something in history. Application was run in history. What is the name of the program? Okay, first of all, we want to check the PS list. And maybe we could see here the answer already. I will leave it. So clear window in volatility free. Let's try to run the PS list, and we can see some time. You can see that all was run in 22nd of March, and they are saying they are talking about 7th of March. There is nothing like this. So where are the artifacts which could trace the program execution from history? I think that there is AM cache, shim cache, and other stuffs. So basically we could try plugins shim cache, but there is nothing like shim cache in volatility free. So we should jump back to volatility 2. There is no shim cache or AM cache. So we have to jump back to volatility 2. We should already know the answer here. This was the question about what the memory partition the virtual address descriptor starting at this address, ending of this address. So starting 33C 000 33C 000. Yep. And ending 33DFFF. Ending 33DFFF and starting 33C 000. This is the one, and here is the protection page no access. So copy, paste, submit, and correct. So question 13, what is the name of the process? So jump back to volatility 2, clear window, and try to find all useful plugin. Where we can use. Based on my experience, the most reliable is Shimcache plugin. AMCache is not so reliable. So here is AMCache. It holds the artifacts about some program execution from history. Here it should be some Shimcache, and maybe user assist should be quite interesting too. So we could try, for example, Shimcache. I like this module. Let's run it like this. And pipe it, select string. Select string, and what is the date? They are asking about 2019. Okay, copy that and paste it. This is correct format for volatility, so it should be okay. We can check what is the next question. What was the written in the notepad.exe at the time when the memory dump was captured? Okay, that's also question from for the volatility 2, but it's also able to solve it in volatility 3, but I will show you volatility 2. Let's check this. Yeah, we have correct answer. Check it. 2019 03 07 23 06 58 23 06 58. Yeah, that's correct. So they are asking what about the application name with exe. included extension here, submit, and it's correct. What was written in Notepad here should be a plugin, you can see, which is basically called Notepad plugin. MN Notepad list currently displayed Notepad text. Nice. So it's really nice, but I think it it doesn't wouldn't be reliable. You can see this command does not support the profile. Okay, so I will do it in the old way. There is a plugin called memdump because we want to dump all the memory space from the process, not only the main module process range, but all process range. There should be some text related to the flag required for answering the question. So you can do it like memdump and check the options from memdump. And memdump bit and dump dir. So memdump, we want to dump the notepad. We have to find out what is the notepad. What is the notepad process ID, where it was PS list notepad. Yeah, I'm doing something wrong here. I already know what is wrong. So I can specify PS list and select string notepad. Wrongly type notepad. We can find out the process ID. We can see the process ID is free or free2. Copy that, specify that we want to dump it, arguments P and argument D, dump it, and dump dir should be this one. It will, okay, what is wrong? Error, no such option D. Yeah, because this the plugin is process dump. Because if you are in volatility free and try to specify, for example, Windows PS list, yeah, this was correct, and try to find the help, you can see that PS list is taking as arguments process ID and it is able to dump it. Yeah, but volatility 2 needs a process dump plugin. For that, you can see it here. If you check it here, you can see it in volatility 2 directory, or where it is. Yeah, sorry, I used wrong plugin. I need memdump of this process, like this. This is quite not interesting because you cannot see here any interesting, you will not see any interesting strings here, probably because this is the space of the process main module and not, for example, the stack or heap and other interesting memory ranges where probably the text was, if you are starting to typing something in Notepad, it will be probably saved in some heap or a stack and other stuffs, not in the main module process range. So this we don't need anymore. And you can see here, it's already done. Yeah, we dump it and we can see it here. Dump big, because this is the all memory range of the Notepad exe process. So let's try to find the interesting strings. You can do it like this: flare strings. It is able to dump Unicode and ASCII strings, path to our file, and pipe it to select string, and here should be some pattern. And if you check, here is the help. What was written in the notepad, and you can see here is the flag. Something underscore something. So we can try to find it here. Flag, like this, simple match, no regular expression, and try it. Basically, this will dump all strings from this dump, notepad exe process dump, and you can pipe all the strings to select string and find flag. This one. It should work. We will see. What is the next question? What is the short name of the file at record? Yeah, basically it's a question related to MFT record, master file table of NTFS file system. So we can search for that. There is plugin in Volatility 2 for that. What we got here? No, this is not what we wanted. Yeah, here is the question. This box was exploited and is running MetaPreter. What was the infected process ID? We already found out it. I will answer it later. So we have like 3 last question. 14, 15, 16. 14 should be in. Yeah, here is 4. Flag Red Bull is live. Nice. Paste, submit. What is the short name? So here is a plugin for that. You can do it like help. There should be some plugin related to MFT. So try to do it like this: pipe, select string, MFT, and you can see MFT parser. Scans for address potential MFT entries. Copy that and specify it here. Delete this and try to again select string and specify the record, which was this one, file record. And what is the next one? Context, because we want to see some context from the record, and after the record should be some upper, so context like 5 and 20 maybe. And let it run. What we got next? The last one is that this box was exploited and running MetaPreter. What was the infected process ID? So the box was exploited and is running MetaPreter. What was the infected process ID? This is quite an interesting question because it's basically another misleading question. You can use PS3 in volatility free and check it here. The process which is running MetaPreter session is the one which has the strange name here, the randomly generated. Here it is, and you can see this is the 100% the malicious infected process W script. But what is this HFS? They mean this one or this one, because this is the parent process for this one process where the MetaPreter is running. So we can try this process ID basically, And if we are wrong, we should try the parent process, the main parent process, because the hfs.exe is a parent for wscript.exe, and wscript is parent for this one. But we will try to 3496. Submit, and it's correct. Nice. And try to see here the records. What we got? We have only one hit. No, here is the hit. We are trying to search for 59045, and you can see here is some match 59049, but this is a data stream, so it's a false positive. We want to search for a record number. It's here, and you can see here are some stuff related to it. Yep, here is the file name, and they are trying to they want the short name. Yeah, short name. So the short name is basically here. Here is the short name, and here is the long name. Yep. So we can copy that and paste it. That should be correct. Oh well, there is something strange. Employee one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is something strange. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Submit, and correct. That's all. Okay, and that's all. Thank you for watching. I hope you enjoyed it. It was quite difficult, but what I wanted to mention, this is for free. It was quite fun, and it's really educational, and it's for free. Again, they spent much time for preparing these stuffs, and I really appreciate it. What I wanted to say about is that there are always misleading questions in memory forensics challenges, and even if even the creator could have some probably wrongly expected answers. I know what they mean, they know what they mean, but it's not correct. Okay, thank you for watching, and I hope you enjoyed it, learn some things, learn some new tricks, and see you again next time.